According to the National Fire Protection Association, or NFPA 20, overcurrent protection is required for fire pump feeders. Specifically, Section 4.16 2.2 requires overcurrent protection for fire pump controllers and their feeders, with the following exceptions. Firstly, feeders to controllers rated less than 100 horsepower or 75 kilowatts. Secondly, feeders where the fire pump controller includes integral overcurrent protection. The distance from the main has no bearing on the overcurrent protection requirement for fire pump feeders. The size of the overcurrent device for a fire pump feeder is based on the motor rating. According to NFPA 20, Section 4.16 2.3 requires the overcurrent device to be sized and not less than 600% of the motor full load current rating. The overcurrent device must be located in the fire pump switchboard as close as possible to the point where the feeder connects to the switchboard. Despite the common misconception that fire pumps do not require overcurrent protection, NFPA 20 explicitly requires overcurrent devices for fire pump feeders. The device must be sized at 600% of the motor full load current rating and located in the fire pump switchboard. Let's delve deeper into understanding the nuances of fire pump feeder overcurrent protection as dictated by NFPA 20. The primary goal of overcurrent protection is to safeguard the electrical system from damage caused by excessive current, which can result from short circuits, ground faults, or overloads. While it is true that fire pumps are critical life safety systems that must remain operational during emergencies, this does not negate the need for overcurrent protection. Instead, the code provides specific guidelines for sizing and locating these devices to ensure both protection and reliability. The exception for feeders to controllers rated less than 100 horsepower or 75 kilowatts suggests that smaller fire pump installations may have a reduced risk profile, justifying the omission of dedicated overcurrent protection at the feeder level. However, it is imperative to verify that the fire pump controller itself incorporates integral overcurrent protection as mandated by the code. This integral protection must meet the same performance requirements as a separately installed overcurrent device. The second exception, concerning feeders where the fire pump controller includes integral overcurrent protection, highlights the importance of a coordinated protection scheme. If the controller is equipped with a listed and approved overcurrent protective device, then a separate device at the feeder is not required. This simplifies the installation and reduces the potential for nuisance tripping, provided that the controller's overcurrent protection is adequately sized and maintained. The fact that the distance from the main has no bearing on the overcurrent protection requirement underscores the principle that protection must be provided regardless of the feeder length. The potential for faults and overloads exists regardless of the distance from the source. Therefore, the overcurrent protection must be located as close as possible to the fire pump switchboard to minimize the unprotected conductor length. The requirement to size the overcurrent device and not less than 600% of the motor full load current rating is a critical aspect of fire pump feeder protection. This seemingly high value is intended to prevent the overcurrent device from tripping during the motor's inrush current, which can be significantly higher than the normal running current. Fire pump motors are often subjected to frequent starts and stops, and the overcurrent device must be capable of withstanding these inrush currents without causing unnecessary interruptions. The location of the overcurrent device in the fire pump switchboard is essential for ensuring effective protection. By placing the device at the point where the feeder connects to the switchboard, the entire feeder is protected against overcurrent conditions. This minimizes the potential for damage to the feeder conductors and associated equipment. In summary, fire pump feeders require overcurrent protection in accordance with NFPA 20. The overcurrent device must be sized at 600% of the motor full load current rating and located in a fire pump switchboard. Exceptions may apply for smaller installations and where the fire pump controller includes integral overcurrent protection. It is crucial to consult NFPA 20 and other applicable codes and standards to ensure compliance and proper installation of fire pump feeder overcurrent protection. Failure to comply with these requirements can result in serious safety hazards and equipment damage. When dealing with fire pump installations, it's essential to remember that these systems are designed to operate under extreme conditions, often during emergencies where the electrical grid may be unstable. Therefore, the overcurrent protection must be both reliable and selective, meaning it should only trip when a genuine fault or overload condition exists and not due to transient voltage dips or other temporary disturbances. Furthermore, it is important to consider the coordination of overcurrent devices throughout the entire electrical system. The fire pump feeder overcurrent device should be coordinated with upstream and downstream devices to ensure that the fault is cleared by the nearest device, minimizing the impact on other loads. This coordination study should be performed by a qualified electrical engineer and documented for future reference. Regular testing and maintenance of the fire pump feeder overcurrent device are also crucial for ensuring its proper operation. The device should be tested periodically to verify that it trips within its specified time current characteristics. Any signs of damage or deterioration should be addressed immediately. In addition to the overcurrent protection requirements outlined in NFPA 20, other codes and standards may also apply depending on the specific installation. For example, the National Electrical Code, or NEC, provides general requirements for electrical installations, including fire pumps. It is important to consult all applicable codes and standards to ensure that the fire pump installation is safe and compliant. When selecting an overcurrent device for a fire pump feeder, it is important to consider the device's interrupting rating. The interrupting rating is the maximum fault current that the device can safely interrupt without causing damage to itself or the surrounding equipment. The interrupting rating must be greater than the available fault current at the point of installation. In many cases, molded K-circuit breakers or fuses are used for fire pump feeder overcurrent protection. Molded K-circuit breakers are electromechanical devices that automatically trip when an overcurrent condition is detected. Fuses are single-use devices that melt and open the circuit when an overcurrent condition occurs. Both types of devices have their advantages and disadvantages, and the selection should be based on the specific application requirements. Regardless of the type of overcurrent device selected, it is important to ensure that it is properly labeled and identified. The label should clearly indicate the device's ampere rating, interrupting rating, and other relevant information. This will help to ensure that the device is properly maintained and replaced when necessary. In addition to the overcurrent protection requirements, fire pump feeders must also be protected against ground faults. Ground faults occur when a current-carrying conductor comes into contact with a grounded surface such as the metal enclosure of the equipment. Ground faults can cause severe damage and pose a significant safety hazard. Ground fault protection is typically provided by a ground fault relay, which detects the flow of current to ground and trips the circuit breaker. The ground fault relay should be set to trip at a relatively low current level to minimize the potential for damage. The installation of fire pump feeders should be performed by qualified electrical contractors who are familiar with the applicable codes and standards. The contractor should carefully follow the manufacturer's instructions for installing and connecting the overcurrent devices and ground fault protection. It is also important to ensure that the installation is properly inspected and tested before being placed into service. Regular inspections and testing are essential for ensuring the continued reliability and safety of the fire pump system. The inspection should be performed by qualified personnel who are familiar with the system and the applicable codes and standards. The testing should include verification of the overcurrent protection and ground fault protection, as well as the overall performance of the fire pump. Any deficiencies or problems that are identified during the inspections and testing should be addressed promptly. In conclusion, fire pump feeders require overcurrent protection and ground fault protection to ensure the safety and reliability of the system. The overcurrent protection must be sized and located in accordance with NFPA 20 and other applicable codes and standards. Regular inspections and testing are essential for maintaining the system's performance and identifying any potential problems. By following these guidelines, it is possible to provide a safe and reliable fire pump system that will protect lives and property. Let's consider some practical examples to illustrate the application of these principles. Suppose a fire pump motor has a full load current rating of 100 amps. According to NFPA 20, the overcurrent device must be sized at not less than 600% of the motor full load current rating. Therefore, the overcurrent device should be sized at 600 amps. This means that a 600 amp circuit breaker or fuse would be selected to protect the fire pump feeder. It is important to note that the actual size of the overcurrent device may need to be adjusted based on the specific characteristics of the motor and the feeder conductors. Factors such as the motor's starting current, the conductor's ampacity, and the ambient temperature may all influence the selection of the overcurrent device. In another example, suppose the fire pump controller is rated at 75 kilowatts, which is approximately 100 horsepower. In this case, an exception may apply, and a separate overcurrent device at the feeder may not be required. However, it is essential to verify that the fire pump controller includes integral overcurrent protection that meets the requirements of NFPA 20. If the controller does not have integral overcurrent protection, then a separate device must be installed at the feeder. In addition to the sizing and location of the overcurrent device, it is also important to consider the type of device that is selected. Molded case circuit breakers and fuses are the most common types of overcurrent devices used for fire pump feeders. Molded case circuit breakers offer the advantage of being resettable, which means that they can be tripped and reset multiple times. Fuses, on the other hand, are single-use devices that must be replaced after they have been tripped. The selection of the type of overcurrent device should be based on the specific application requirements and the preferences of the owner or operator. It is also important to consider the interrupting rating of the overcurrent device. The interrupting rating is the maximum fault current that the device can safely interrupt without causing damage to itself or the surrounding equipment. The interrupting rating must be greater than the available fault current at the point of installation. The available fault current can be calculated using engineering software or by performing a short circuit study. It is essential to ensure that the overcurrent device has an adequate interrupting rating to protect the electrical system from damage. Ground fault protection is another important aspect of fire pump feeder protection. Ground faults occur when a current-carrying conductor comes into contact with a grounded surface such as the metal enclosure of the equipment. Ground faults can cause severe damage and pose a significant safety hazard. Ground fault protection is typically provided by a ground fault relay which detects the flow of current to ground and trips the circuit breaker. The ground fault relay should be set to trip at a relatively low current level to minimize the potential for damage. The installation of fire pump feeders should be performed by qualified electrical contractors who are familiar with the applicable codes and standards. The contractor should carefully follow the manufacturer's instructions for installing and connecting the overcurrent devices and ground fault protection. It is also important to ensure that the installation is properly inspected and tested before being placed into service. Regular inspections and testing are essential for ensuring the continued reliability and safety of the fire pump system. The inspection should be performed by qualified personnel who are familiar with the system and the applicable codes and standards. The testing should include verification of the overcurrent protection and ground fault protection, as well as the overall performance of the fire pump. Any deficiencies or problems that are identified during the inspections and testing should be addressed promptly. By following these guidelines, it is possible to provide a safe and reliable fire pump system that will protect lives and property. The coordination of overcurrent protective devices in a fire pump system is crucial for ensuring selective tripping and minimizing disruptions during a fault condition. Coordination involves selecting and setting the overcurrent devices in such a way that the device closest to the fault will trip first, isolating the problem without affecting other parts of the system. This is typically achieved through a time current coordination study, which analyzes the time current characteristics of all overcurrent devices in the system and ensures that they are properly coordinated. The study takes into account the available fault current, the conductor ampacity, and the motor starting characteristics. The goal is to create a system where the overcurrent devices are able to discriminate between normal operating conditions, overload conditions, and fault conditions. The overcurrent devices should be set to trip quickly under fault conditions to minimize damage to equipment, but they should also be able to withstand the motor starting current without tripping unnecessarily. The time current coordination study should be performed by a qualified electrical engineer who has experience in fire pump system design. The study should be documented and updated whenever there are changes to the electrical system. In addition to the time current coordination study, it is also important to consider the maintenance and testing of the overcurrent protective devices. Overcurrent devices should be inspected and tested regularly to ensure that they are functioning properly. Circuit breakers should be exercised periodically to prevent them from becoming stuck. Fuses should be inspected for signs of damage or deterioration. The testing should include verification of the overcurrent device's tripping characteristics. The overcurrent device should be tested to ensure that it trips within its specified time current curve. The testing should be performed by qualified personnel using calibrated test equipment. Any overcurrent devices that fail the testing should be replaced immediately. Proper maintenance and testing of overcurrent protective devices are essential for ensuring the reliability and safety of the fire pump system. The failure of an overcurrent device to operate properly can have serious consequences, including damage to equipment, fire, and injury. Therefore, it is important to take the necessary steps to ensure that the overcurrent devices are in good working order. In addition to the technical aspects of fire pump feeder overcurrent protection, it is also important to consider the regulatory requirements. Fire pump systems are subject to strict regulations by local, state, and national authorities. These regulations are designed to ensure that fire pump systems are safe and reliable. The regulations typically require that fire pump systems be inspected and tested regularly. The inspections and testing must be performed by qualified personnel who are certified to perform the work. The regulations also specify the types of overcurrent protective devices that are allowed to be used in fire pump systems. The regulations may also require that the overcurrent protective devices be coordinated to ensure selective tripping. It is important to be familiar with the regulatory requirements that apply to fire pump systems in the jurisdiction where a system is located. Failure to comply with these regulations can result in fines, penalties, and even the shutdown of the fire pump system. Therefore, it is important to work with qualified professionals who are familiar with the regulatory requirements. In conclusion, fire pump feeder overcurrent protection is a complex topic that requires careful consideration of both technical and regulatory factors. By following the guidelines and recommendations outlined in this discussion, it is possible to design, install, and maintain a safe and reliable fire pump system that will protect lives and property. The ongoing maintenance and periodic testing of fire pump systems are critical for ensuring their continued reliability and effectiveness. Regular maintenance helps to identify and address potential problems before they can lead to system failures. Periodic testing verifies that the system is functioning as designed and that all components are operating within their specified parameters. Maintenance tasks for fire pump systems typically include inspecting and cleaning the pump, motor, and controller, lubricating moving parts, checking fluid levels, and verifying the condition of electrical connections. Testing procedures usually involve starting the pump and measuring its flow rate, pressure, and electrical characteristics. The results of the testing are compared to the manufacturer's specifications to determine if the system is performing adequately. Any discrepancies or anomalies are investigated and corrected. It is important to maintain detailed records of all maintenance and testing activities. These records can be used to track the system's performance over time and to identify any trends or patterns that may indicate potential problems. The records can also be helpful in troubleshooting problems and in planning future maintenance activities. The frequency of maintenance and testing will vary depending on the type of system, its operating conditions, and the applicable regulatory requirements. However, as a general rule, fire pump systems should be inspected and tested at least annually. In some cases, more frequent maintenance and testing may be required. For example, systems that are located in harsh environments or that are subjected to heavy use may need to be inspected and tested more often. It is also important to perform maintenance and testing whenever there are any changes to the system, such as repairs or modifications. The maintenance and testing should be performed by qualified personnel who are familiar with the system and the applicable codes and standards. The personnel should have the necessary training, experience, and equipment to perform the work safely and effectively. It is also important to ensure that the personnel are properly licensed and certified. Failure to properly maintain and test fire pump systems can have serious consequences. The system may not operate properly in the event of a fire, which could lead to significant property damage and loss of life. Therefore, it is essential to take the necessary steps to ensure that fire pump systems are properly maintained and tested. The integration of fire pump systems with building automation systems, or BAS, is becoming increasingly common. Building automation systems can provide a variety of benefits for fire pump systems, including remote monitoring, automated testing, and improved energy efficiency. Remote monitoring allows operators to monitor the fire pump system from a central location. This can be helpful in identifying potential problems early on and in responding quickly to emergencies. Automated testing can be used to automatically test the fire pump system on a regular basis. This can help to ensure that the system is functioning properly and that all components are operating within their specified parameters. Improved energy efficiency can be achieved by optimizing the operation of the fire pump system. For example, the system can be programmed to run at a lower speed when there is no demand for fire protection. The integration of fire pump systems with building automation systems can be complex, and it is important to work with qualified professionals who have experience in this area. The professionals should be familiar with the applicable codes and standards and should have the necessary training and equipment to perform the work safely and effectively. It is also important to ensure that the building automation system is properly configured and programmed to meet the specific needs of the fire pump system. The use of variable frequency drives, or VFDs, in fire pump systems is becoming more common. Variable frequency drives can be used to control the speed of the fire pump motor. This can provide a number of benefits, including improved energy efficiency, reduced wear and tear on the motor, and smoother starting and stopping. Improved energy efficiency can be achieved by operating the fire pump motor at a lower speed when there is no demand for fire protection. This can significantly reduce the amount of energy consumed by the system. Reduced wear and tear on the motor can be achieved by reducing the stress on the motor during starting and stopping. Variable frequency drives can provide a smoother starting and stopping profile, which can help to extend the life of the motor. Smoother starting and stopping can also reduce the risk of water hammer, which is a phenomenon that can occur when the flow of water is suddenly stopped or started. Water hammer can damage the fire pump system and can even cause pipes to burst. The use of variable frequency drives in fire pump systems requires careful consideration of the system's design and operating characteristics. It is important to work with qualified professionals who have experience in this area. The professionals should be familiar with the applicable codes and standards and should have the necessary training and equipment to perform the work safely and effectively. It is also important to ensure that the variable frequency drive is properly sized and configured for the fire pump motor. The selection of conductors for fire pump feeders is a critical aspect of ensuring the reliability and safety of the system. The conductors must be sized to carry the full load current of the fire pump motor, as well as any additional loads that may be connected to the feeder. The conductors must also be able to withstand the high inrush current that occurs when the motor starts. The National Electrical Code, or NEC, provides detailed requirements for sizing conductors for fire pump feeders. The NEC specifies the minimum ampacity of the conductors, as well as the allowable voltage drop. The NEC also provides guidance on the selection of conductor insulation and the installation of conductors in raceways or cable trays. It is important to consult the NEC and other applicable codes and standards to ensure that the conductors are properly sized and installed. The conductors should be selected by qualified electrical engineers who are familiar with the fire pump system and the applicable codes and standards. The engineers should consider all of the relevant factors, such as the motor's full load current, the inrush current, the ambient temperature, and the length of the feeder. It is also important to ensure that the conductors are properly protected from overcurrent and ground faults. Overcurrent protection is typically provided by a circuit breaker or fuse. Ground fault protection is typically provided by a ground fault relay. The overcurrent and ground fault protection should be sized and coordinated to protect the conductors from damage. In addition to the technical requirements for conductor selection, It is also important to consider the cost of the conductors. The cost of conductors can vary depending on the size, type, and insulation. It is important to select conductors that are both cost-effective and reliable. The use of uninterruptible power supplies, or UPSs, in fire pump systems is becoming more common. Uninterruptible power supplies can provide a backup power source for the fire pump system in the event of a power outage. This can help to ensure that the system is able to operate during emergencies. Uninterruptible power supplies typically consist of a battery bank, a charger, and an inverter. The battery bank stores energy that can be used to power the fire pump system. The charger keeps the battery bank fully charged. The inverter converts the direct current, or DC voltage, from the battery bank into alternating current, or AC voltage, that can be used to power the fire pump motor. The size of the uninterruptible power supply will depend on the size of the fire pump motor and the desired backup time. The uninterruptible power supply must be able to provide enough power to run the fire pump motor for the required backup time. It is also important to consider the reliability of the uninterruptible power supply. The uninterruptible power supply should be designed to operate reliably in the event of a power outage. The uninterruptible power supply should also be tested regularly to ensure that it is functioning properly. The use of uninterruptible power supplies in fire pump systems requires careful consideration of the system's design and operating characteristics. It is important to work with qualified professionals who have experience in this area. The professionals should be familiar with the applicable codes and standards and should have the necessary training and equipment to perform the work safely and effectively. It is also important to ensure that the uninterruptible power supply is properly sized and configured for the fire pump motor.